Good afternoon. We will carry on with what we have been doing for the past few lectures, that is cover up the various theorems which are an offshoot of the Heckscher-Ohlin model. Please recall, the Heckscher-Ohlin model says that a country exports the good which uses intensively the abundant factor and imports the good which uses intensively its scarce factor. In crude terms, it would mean that a country which is rich in capital will export capital intensive product, and a country which is rich in labor will export labor intensive product. Now, in the real world, there are more than two factors, there are more than two countries, there are more than two goods. The basic Heckscher-Ohlin model is about 2 into 2 into 2 model. It is two factors, two goods, two countries, and it talks about factor intensities which are easy to define in a 2 into 2 into 2 model, because if the capital labor ratio in industry 1 exceeds the capital labor ratio in industry 2, you say that the first industry is capital intensive, the second industry is labor intensive. If you have to talk about abundance, you say capital labor ratio, the overall capital labor ratio in country A, if it is greater than the capital labor ratio in country B, you say that country A is capital abundant, country B is labor abundant. Problem comes when you have more than two goods, you have more than two factors of production, you have more than two countries. Then you need to define what do you mean, how do you define factor intensities, how do you define factor abundance. So, after this, when we discuss the Heckscher-Ohlin-Weenek theorem, you will see how Weenek in 1968 contributed to this literature on the HOV, and how he related factor content, say labor content or capital content in net exports to factor abundance, capital abundance, labor abundance. But before we do that, I want to finish up the proof of the Stopler-Samuelson theorem, which is another offshoot of the Heckscher-Ohlin 2 into 2 into 2 model, that a rise in price of a commodity raises the real reward of the commodity of the commodity's intensive factor, and a decline in real reward of its unintensive factor. Now, the proof dates back to 1949, and it can justify what US was doing at that time. This is the time from 1930 till the end of the Second World War in 1945. It had raised protectionist barriers, it was increasing the tariff rates, but then it had to decide on which goods should it impose tariffs, and everyone knew that US was capital rich, at least it was human capital rich, and it was scarce in labor endowments. So, if it had to protect its labor, then what US was doing was that it was imposing tariffs on all labor intensive products coming from the foreign countries. And the reason was that with tariffs, you already know that when you impose tariffs on the labor intensive products coming in, it will raise the domestic price of the labor intensive good in your country. So, this Toppler-Samuelson's theorem says that if there is a rise in price of the commodity, a labor intensive commodity, it will raise the real wage rates in that country and a decline in the real reward for the capital input. So, that is the reason that they impose tariffs, to protect their labor. So, that is where the contribution of Toppler-Samuelson came, where they linked the commodity price with the factor price. And if you work further on this, then you can prove the factor price equalization theorem, which says that at the end the relative wage rates would be the same once trade takes place. Trade is a substitute for factor movements. Even if you do not have mobility of factors across countries, trade is a good substitute, because when trade takes place, the relative price of that commodity goes up, the real reward of its intensive factor goes up, the real reward of the unintensive factor goes down. So, if there is a labor rich country, the abundant factor, which is the labor, will gain. In the other country, which is capital rich, the real the rentals to the capital will gain, the abundant factor will gain there. Eventually, you will see that with trade, when the relative prices are same, the relative wage rates would be the same. So, if you further build on this, you can prove the factor price equalization. But in factor price equalization, there are certain things that need to be satisfied, which is that the cone of diversification should coincide. They should not be very far apart as far as technology is concerned, or at the end Heckscher-Ohlin never assumes that the technology is different. Technology is same, but the relative wage rates can be very far apart. Okay, and so even if you have trade, you would not see the equalization of the relative wage rate. So, the relative wage rate should not be very far apart, and it all depends on what is your capital labor ratio, what is the total capital, total labor which is available to you. They should not be very far apart. If they are very far apart, you will not see a factor price equalization. Okay, so to prove the Toppler-Samuelson theorem, we had already derived from the equations of change this particular equation, which said that your wages, the proportionate change in wages and the proportionate change in the rate of return on capital is related to the individual prices. Now, there was a big proof where we first started with assuming that prices are equal to average cost. Then we worked on the equation of change. Then we replaced the values of the unit labor and unit capital requirements, which was Cij star was equal to Aij star minus Bij star. So, the changes in the input output requirement was a function of the change which will happen in the input output ratio due to changes in the relative wage rates and the technology. So, when we did all when we took into account all these changes, and then at the last we assume that the technology does not change, we got this particular equation. Now, once we have this equation, you can always solve for W star using the Cramer method. And R star to be equal to so this was theta L1 P2 star and you had determinant of theta. Now, here you should note what determinant theta means. It means and theta L1 so So, if you take W R L1 L2 to be common and P1 X1 P2 X2 to be common, so you will get K2 by L2 minus K1 by L1. So, this is W R L1 L2 P1 X1 P2 X2 K2 minus K1. Now, you can see that if K2 is greater than K1, this implies determinant theta to be greater than 0. If K2 is less than K1, this would imply determinant theta less than 0. Further, if you work on determinant theta, then you can write theta L1 as 1 minus theta L2, because theta L1 plus theta K1 is 1 So, you get 1 minus theta L2 minus theta K1. Please recall that theta L1 plus theta K1 is 1, theta L2 plus theta K2 is 1. Why? Because the total output totally exhausts the factor payments which are done towards the labor and the capital. So, 1 if it is replaced by the first theta L1 plus theta K1 minus theta L2 minus theta K1, then determinant theta is equal to theta L1 minus theta L2 and if 1 is replaced by theta L2 plus theta K2, then theta L2 and theta L2 cancel. So, you get theta K2 minus theta K1. So, please note these two set of results and determinant theta to be equal to theta L1 minus theta L2, theta K2 minus theta K1. Now, put P1 star and theta K2 is determinant theta plus theta K1 minus P2 star theta K1 divided by determinant theta. Now, this you can write this to be equal to W star minus P1 star is equal to theta K1 P1 star minus P2 star. So, you get W star minus P1 star theta K1 P1 star minus P2 star. Further, W star, if you had written this as theta K2 and this you had replaced theta K1, theta K1 is determinant theta K2 minus determinant theta. So, you would have got W star minus P2 star theta K2 P1 star minus P2 star divided by determinant theta. So, you get theta K2 and you have minus P2 star, and in place of theta K1, you have put theta K2 minus determinant theta. So, you get plus P2 star determinant theta plus P2 star determinant theta. So, that goes here, and then you have minus P2 star theta K2, you have P1 star theta K1, all right. So, you take theta K2 common, P1 star minus P2 star divided by determinant theta. So, you have this, you have this. R star theta L1 P2 star. Theta L1 is determinant theta plus theta L2 P2 star minus theta L2 P1 star divided by determinant theta. So, it becomes R star P2 star plus theta L2 P2 star minus P1 star whole to the determinant theta. So, from here you get R star minus P2 star is equal to theta L2 P2 star minus P1 star determinant theta. Then if you had replaced theta L1 P2 star minus, instead of theta L2, theta L2 is theta L1 minus determinant theta P1 star divided by determinant theta you would have got W star R star minus P1 star theta L1 P2 star minus P1 star determinant theta. So, we have 1, we have 2, we have 3, 4. So, 1 and 2 and 3 and 4. So, we have these 4 equations. W star minus P1 star is equal to theta K1 P1 star minus P2 star divided by determinant theta. We have W star minus P2 star theta K2 P1 star minus P2 star determinant theta. P1 star is the proportionate change. We have R star minus P2 star theta L2 P2 star minus P1 star determinant theta. We have R star minus P1 star theta L1 P2 star minus P1 star determinant theta. Now, come back to the Stopler-Samuelson theorem, which says a rise in price of a commodity raises the real reward of its intensive factor and a decline in real reward of its unintensive factor. So, assume that determinant theta, say if K2 is greater than K1, then determinant theta is greater than 0. So, good 1 is labor intensive, good 2 is capital intensive. So, what happens if the price of the labor intensive product goes up, that is P1 goes up, there is no change in P2 if P1 goes up. So, look at this equation, this is the unit capital requirements, it is always positive. This determinant we have assumed to be positive, P1 star is positive, P2 star there is no change. So, the entire thing is positive, it is greater than 0. So, W star is greater than P1 star. So, what it means is if determinant theta is greater than 0, K2 is greater than K1. If P1 increases, this implies W by P1 ratio goes up. Why? Because W star minus P1 star is greater than 0. This follows because W star minus P1 star is greater than 0. This implies that W by P1 ratio goes up with an increase in prices. So, the real wage rate in terms of the price of the first commodity goes up. Okay. What about if you look at the second, if you look at okay, we were looking at the second, look at the first. If P1 goes up, there is no change in P2 star, assuming determinant theta to be greater than 0. if P1 increases, P1 star positive, so all this positive. So W star minus P2 star greater than 0, W star greater than P2 star. If the increase proportionate change in wage is greater than the proportionate change in the price of the second commodity, it means that W by P2 ratio goes up as P1 increases, as P1 goes up, because W star minus P2 star is greater than 0. So a rise in price of a commodity raises the real reward of its intensive factor. So the price of the labor intensive product had gone up, so it increased the real reward of its intensive factor, it increased the real wage rate in terms of price P1 and P2. So this is what you need to see, this is what has happened. But there is something in addition to this. There is a decline in real reward of its unintensive factor. Now you need to look at equation 3 and equation 4. Now what happens if P1 goes up? If P1 goes up, there is no change in P2, this is negative. So R star is less than P1 star. So what does it mean? R by P1 ratio goes down. So this implies R by P1 ratio going down as P1 goes up. What about R by P2? You can see if if P1 goes up, there is no change in P2, this is a negative amount. So R star is less than P2 star. So R by P2 ratio goes down with an increase in price of the first commodity. Now this is mathematics. What is the economics intuitive thing which is going on? When the price of a commodity goes up and it is a labor intensive product, then it will force producers to produce more of that commodity, because now they are getting higher price for that. And because it is a labor intensive commodity, there will be an increase in relative demand for labor. So when it increases the relative demand for labor, the wage rates go up. That is the reason that you see that the wage rates go up, and because of this thing which led to an increase in labor intensive product, there is a decline in price of the capital intensive product. So when there is a decline in the production of the capital intensive product, the relative demand for capital goes down. When the relative demand for capital goes down, the R by the rental, it also goes down. So you see this happening. Now, yeah.
Decrease in price of capital intensive good is because the people are shifting from capital intensive to labor intensive.
No, because P1 by P2 ratio has gone up, right? So it is equivalent to saying that P2 by P1 ratio goes down. Or when if you do not want to take into account the relative prices, say P1 goes up, then you are right that as the production of labor intensive good goes up, because you are on the PPF, as the production of labor intensive product goes up, there has to be a decline in the production of the other commodity. That has led to a decline in the prices and the real reward for the capital, right. So here we are not even talking of the relative prices, we are talking of one price which is changed, that is P1. Now you can always see these equations in terms of what would have happened if determinant theta is less than 0. If determinant theta would have been less than 0, then it would have implied that good 1 is capital intensive, good 2 is labor intensive. So if good 1 is capital intensive, and if the price of the capital intensive product goes up, if the price of the capital intensive product goes up, then you can see from this equation, these R star equation. Now, good 1 is the capital intensive product, but then the determinant theta is less than 0. So, even if P1 goes up, you would see an increase in R by P1 ratio, because R star minus P1 star is greater than 0, because determinant theta is less than 0. And if you look at these equations, if P2 star goes up, see what happens to P1 star goes up and determinant theta is negative, you would see that W star minus P2 star would be less than 0. So, the relative wage rates would go down. So, you would always see that a rise in price of a commodity raises the real reward of its intensive factor and a decline in real reward of its unintensive factor. Further, a small point on the magnification effect. Now, you can see you have got this equation, and if there is no change in say P2, then you can always express this as W star by P1 star minus 1 equal to theta K1 determinant theta. So, W by P1 star is equal to theta K1 determinant theta plus 1. Okay. And then R star say by P1 star R star by P1 star minus 1 Now, look at these two equations. If determinant theta is greater than 0, that means good 1 is labor intensive, good 2 is capital intensive. You would have this relative wage rate to be equal to 1 plus this. So, W star is greater than P1 star, is greater than P2 star, is greater than R star. This is the magnification effect. That means, if the price of first commodity increases, wages also go up, but the increase in wage is greater than the increase in prices. Increase in price is greater than the increase in price of the second commodity. This is greater than the change in the rate of return on capital. I say change because in R you see a decline, but the proportionate decline, this is the least. So, magnification is price increases, wages go up, but the increase in wage is greater than the increase in prices. Increase in price is greater than the increase in the price of the second commodity, and this is greater than the proportionate change in the rate of return. This is the famous magnification effect, which follows from the Stopler-Samuelson theorem. So, then if this is the Stopler-Samuelson theorem, if we want to test the Stopler-Samuelson theorem, we should have an econometric equation, and that econometric equation will follow from the Heckscher-Ohlin-Weynick model, and there we can test for the Stopler-Samuelson hypothesis that a change in price of a commodity changes the returns on returns of the factors. So, tomorrow in the next lecture we will discuss the empirical testing of the Heckscher-Ohlin model. We will start by discussing the famous Leontief's paradox. Leontief, who first tested the Heckscher-Ohlin model in 1953 with the data which was available for 1947, and he found a paradox. We will give some explanations of the Leontief's paradox, and then subsequently discuss Lemur's work, who questioned the methodology of Leontief and proved that what Leontief was doing was not correct. He suggested an alternative methodology, and then once you have the Heckscher-Ohlin-Weyneck equation which relates factor content with factor abundance, then you can see that you can test Rysbinski theorem. You can also test Stopler-Samuelson, and once you have this equation, you can test the Heckscher-Ohlin-Weyneck theorem by using the partial and the complete tests. So, my next lecture will be about the Leontief's paradox and the Heckscher-Ohlin-Weyneck theorem and many offshoots which come out of the HOV model. Okay, thank you so much.